Okay. Next we're going to look at a problem, and then we're going to see how different it is whether you implement it via a stack or a queue. This problem we're going into is actually a very common problem that you will probably see more than once during your career, so it is something definitely to look at. All right. We like mazes, right? Yes? Of course we do. Okay. And let's say we have a grid, just to make our lives easier. And we'll say that your start point is here, your end point is here, and anything empty you are allowed to move to, but we might put some walls in here. And the question is, if you're only allowed to go up, down, left, and right, if you start here, can you make it there? So, that's the question. Okay, obviously in here, we can see that there is a path to go there. But the question is, how do we write a program to determine this? Any ideas? It's only 8:35. I've given you 35 minutes to warm up.
You're going to have to use a lot of checks to figure out where the walls are. And if there is a wall, you have to try a new direction.
Okay. Okay, well, let's roll this back. I'm not saying you're wrong. What I'm saying is one way to approach these problems is that if you were to do it by hand, what would you do? And you kind of have to pretend you're a computer, and you can only see this thing. You're right here. What would you do first?
Mark that you were there.
All right, so we can mark that we were here. Then what do we do? We can see this way, we can see that way. All right, we'll try one of them. So we'll try this way. So we'll put a V saying where we're visiting. Then what do we do?
Visit it and make sure it's not a wall.
Well, right, we can check that it's not a wall by looking at. Okay, yeah. So we're not on a wall. Great.
Alright, and then go there.
Now we'll mark it. Now what do we do? I guess since we tried going right, we should try going right again. So we're over here. Wait a minute. All right, we're on a wall. We can't be there, right? So what do we need to do?
Gotta try a new direction.
We need to go back first,
Yeah.
right? We got to go back. Now, this is very important. We started here, we tried here, we're here. We need to go back. So we can go back. So let's do this. We went to 0, 0. Then we went to 0, 1. Then we went to 0, 2. Found out that was wrong. We're back to 0, 1. Now what do we do? Try going, just pick a direction. Down? Yeah, so we'll try going down. I'm writing it in a certain way. 0, 1, 1. Are we good? All right, so we'll mark it. Now what do we try and do? Well, so far we've always tried going right, so we need to try going right again. Is that good? No, so we need to.
So you have to go back.
So we need to go back. And last time we tried going down, so let's try going down. Are we allowed to be there? No, all right. Get rid of that. All right, now we've tried going right, we've tried going down. What should we try next?
Go left.
Go left, okay. So we can go left. And what's that? By the way, don't ask me why. Upper left is 0, 0. This is bigger down here. Well, you can ask me why, and I can tell you. Do y'all know why? So, in your old computing systems, back in the day of old, you didn't print pixels or anything like that. You printed characters. So, and if you were on a good machine, on a normal machine, you'd have 40 characters per line, and then you'd have 24 lines going down. And so you'd print up here, and you'd keep printing from the top down, like a sheet of paper. That's the way it was done. Because when you originally printed, you were actually printing to a printer, aka a physical printer. And then eventually that turned into an electronic printer, you know, a monitor with characters. And eventually that evolved into, oh, hey, look, we can have GUIs, and then it kind of evolved into what we have now. So yeah, 00 is up here. Welcome to life. Okay, 00. So we're here. Are we allowed to be there? All right, Are we allowed to be there? Yeah, so we're currently visiting this. We'll mark it here. All right. Well, every time we do this, we try going right. This is where things get interesting. So let's try going right. Back to 1, 1. Can we go right?
Yep.
Yeah, yes. Okay, technically
Technically,
yes. But why should we say that we can't?
Because we've already visited.
Because we've already marked it. So that's bad. So let's go back. Then we tried right, so let's try going down. Imagine. Can we go there?
Yep.
Yeah, so we marked. All right, guys. What is this over here?
Coordinates.
Mm-hmm.
That's
And
that.
storing them in a stack. Y'all see that? I am storing, so the one, so the type of searching that we have intuitively begun doing is called, well, it's called a depth first traversal, and it utilizes a stack, because we're going to try and go all the way in one direction until we can't, and try and back off until we don't need to anymore. All right. So let's code this up. All right, we got the template. We'll copy it to 10.9. We'll call it depth first search. Well, let's see. How do we want to do this? Source. Oh, we called it unit? Sure, we'll call it unit. Oh, that's interesting. All right, so we'll do. So the question we're asking is, can we get from the beginning to the end, right? So we're returning a Boolean. And I'll call it is possible. And we're passing it an int array, right? So int arrow. Actually, we're passing it a double int array with a width and a height. And then we also need to know our start index, start position, or we could implicitly say our start position is 0 and our end position is over here. We'll, let's see. We'll go ahead and do that.
Your window isn't fitting on
Yeah, someone needs to go full screen.
the, or no, I mean on the projector.
Oh, hey, look at that. Oh,
I don't know, it's tricky for patterns.
it does. Someone broke it. Sorry about that. Let's see if I can. How about that? There we go. It's called is possible, but really it's I'll call it depth first search, unless you really want me to type out depth first search. Y'all good with that? Okay, great. And we'll make a unit.cpp. Hey, look at that. Okay. All right, there's that. Let's go set up our test cases. So test, empty test, test, and we'll do depth first search test. That's CP. And then we'll tab new, test, depth first search. All right, great. So if we want to do this, we need to probably come up with an array to test this. So we'll go int, equals Huh. And that's kind of weird. All right, we need to come up with, what do we do, 1, 2, 3, 4, 5? Sure. So we need to come up with a way to say that it is not, that it's empty. So let's go use the value 0 for that. Other languages we could use enums, but we're going to stick with this for now. And this is a double array, so we need to do it this way. Okay. Let me make sure this compiles, because it might not. Warning, no return statement and function returning non-void. Error, scalar object requires one element in initializer. There's your one element. It does not like me. Scalar object requires one element initializer, line 14. 14's right there. You're lying. It may want that. That's not what it wants. So these are all integers, right? I'm not missing something. Let's go ahead and do this step by step just to make sure. Scalar object requires one, so I missed it again. Did I forget how to do scalar initializers? Huh! Am I missing something? Curly bracket, semicolon. No, it's all there. All right. All right, Google. C static int array 2D. 2D array initialization in C. Beautiful. Stack Overflow. Where else would... Okay. Hey, that's exactly what I'm doing. Oh. Okay. So that's going to compile. Yep. And then it's going to want this. All right. Fine. And the other one must have a bounds. Of course it does. Oops. Okay. And then, all right, so this is going, we're about ready to have some fun language excursions, because this is not going to be able to be passed to our function, but that's okay. Let's see what happens. So we go back to here, copy this over, depth first search, pass in the array. What's the width? 5? We'll have it start at 0, 0, 0, and end at, what should it end at? Was it 4, 4? Bless you, by the way.
Thank you.
And now we're going to need to fight the compiler a little here, because I don't believe it's going to like this. Was not declared in the scope? Well, that's an easy one. There we are. Cannot convert into an int for argument because it's not actually a double pointer. So instead, we have to actually allocate it. Oh, thanks, C++. All right. Arrow y sub 0 equals that. Put a semicolon there. And I forgot to do this because it's not going to like that. New int. I said int pointer sub 5. Error cannot convert brace and close initialized in assignment. Really, you can't? Oh my goodness. Wow. Cannot convert those in assignment, but it's already pointing to the. All right, fine.
Can't argue with Tyler.
Oh, I can argue, you just won't win.
Yeah.
That's the problem.
Is that how it works in marriage too?
No. But sometimes it seems that way. All right, anyways. So, oh, this is ridiculous. Oh well. Destination. All right, if I remember my syntax correctly, I can do it this way. ARY sub I, and then I can copy all that over and then give it 5. Wow. Oh. No, it'll happen eventually. What, you never have this problem? All right, sub I was not declared in the scope. Well. Oh, it really doesn't like this. Wow. All right. Oh, we don't want to do it that way. Oh, we don't want to do it that way. Oh, we don't. Why is this?
The compiler just wants you to stop.
It does not want me to make it set each one variable one at a time.
Cease and desist.
It really does not like this. All right, so we'll do it the other way then. So create a new int of each one, then inside of here, I equals, or j equals 0, j. This is really absurd, but all right. So we're just going to manually make them all zeros, so you can go to it. What's funny is I remember doing this before. There's got to be something I'm missing. All right, so where are we going to put our walls? 0, 3. We'll say a wall is 1. How about that? That'll be 1, 3, 2, 3, 3, 3, and 4, 3. And then we also have, what is it, 0, 1, 2, and 1. And then we'll also have 0, 1, 2, 3, 4. So we'll have 4 and 0. Okay, there it is. Okay, wow, that was terrible. All right, anyways. Story of my life. All right. Now that that's been set up, somewhat painful, but oh well. But now it's set up and we can copy and paste it inside of a test case and start actually making this work. How do we implement this depth first search? So you said use a stack. All right, here's a very important piece of, I guess, information for you to understand. So we have stack the data structure and we have stack where you store things in memory. How similar are those two things? Pretty similar. When you use recursion, you are using the implicit stack of the language, or in C. The only time that recursion does not use the stack is in Fortran, so don't use that language. Otherwise, you have, well, I should say old Fortran. Fortran before 77 Fortran didn't use the stack. But everything else, there's a stack whenever you call a function. So the stack that we should use, because we need to learn recursion, is going to be the stack of the function calls, which means we're going to do a recursive solution using the stack of the system. Am I making some sense here? The stack, when you do things recursively, you are using the stack. Okay. If we're going to use recursion, then the first thing we need to do is set up the base case. Actually, base cases. Anyone think of what some base cases might be over here?
If the, like, where you're at equals 1, then return
If it equals,
like a wall.
I'm sorry, say I didn't understand. If it,
If, like, we're going through the array, right?
mm-hmm.
And if we're at, like, 0, 2, and it equals 1.
Okay, it equals a wall. All right, so that's a good test. If, and I'm going to change the parameter because we should change this to current x and current y. And that'll make more sense. So if ARY sub current x sub current y is equal to 1, aka a wall, return false, right? Okay, that's a good base case. Any others? Well, how do we know when we've won?
It's 4, 4.
Well, more specifically, if
Oh, index and y.
equals what?
Current x.
Yeah. C cy equals ey. Return true. Okay, great. Anything else? Nothing yet? We can all.
If
Go.
we've visited it.
All right, so we need to come up if it's been marked, right?
Yeah.
We'll say marked as 2. So note 0 is open, 1 is wall, 2 is marked as visited. How's that? Nice little comment. Okay. Anything else? You got this. No?
Do we have to test if it's like outside the bounds at all?
Yeah, probably need to do that. All right, someone write that. I've written 3 of these. It's time for me to stop typing. I'm walking this way.
What is that?
So you check that it's out of bounds, right? That's a great idea. Probably should do that first. So what are we checking the bounds of?
The x and y.
Which x and y? We got 2 x's and 2 y's.
Oh, the current one, I guess.
Right, so we need to do an if on cx, not inside of the array. So back that up to the beginning of the if and type in cx. But no, delete that whole array sub cx sub cy type thing. Yeah. So back, delete again, yeah. So cx. So what would be something cx should not be?
Less than 0.
Less than 0, right? So let's type that. There's another one, or what would also be bad for cx to have?
Greater than that.
Right, so if it was greater than or equal to, which variable would that be?
W.
It's going to be h. I know that seems weird. Or hold on, I get this mixed up all the time. Sure, we'll go with w. Yeah, whatever. All right.
Can it be equal to it though?
Well, if it's equal, remember
yeah,
C is 0 indexed, so if it's equal to it, that's bad. So we want to return false. So let's go and write that. Please do the curly brackets. Yeah. Oh, this is beautiful. I don't have to type. All right. So if we check CX, we should probably also check. Yeah, let's go do that. Hold on, let me help you out real quick. First off, I think you needed. Oh, okay. All right, go ahead.
Quick question.
Yes.
Is CX less than or equal to W?
Ooh, yeah, that'd be bad. I think we meant greater than or equal to. Good check. Good call. Good call. All right, so I copy and paste that line because now we want to, instead of CX, we want CY. So let's change those to CYs. Nice. All right. Wow, look at all that. All right, we've got some. It's a heavily guarded function, right? We're making sure that you cannot get through. Excuse me. All right. So now that CX and CY are valid, and we may visit the current position. What do we do now?
Mark the position.
Ah, great. So let's mark the position, arrow sub C, CX sub CY. And we agreed this time the marked is 2. Good. Mark the position. All right. Now what do we need to do?
Recurse to the right.
So recurse to the right or try going right. Yeah. All right, so let's get that one done. So that will be, this is recursive, so depth first search. We're still passing in the array. We still have the same width and height, but CX is still going to be 0. So you still have CX. Are we changing CY? Yeah, so that one's going to be +1 because we're going to the right. EX and EY are still the same. Okay.
Oh wait, I thought X would be
Yeah,
recursive.
Depends on which way you want X and Y. You want X, we can make X go 1 by 1. It depends which way you want to do it.
It doesn't matter, I guess.
Yeah, I guess it's fine. Albeit it's a little confusing.
Well, think about this. If you're over here, it's very confusing. This is 0, 0. If you go to the right one, X is still 0, Y is now 1. Right? It depends on how you want to look at it.
Yeah.
It depends on how you want to look at it. It's confusing, and it gets worse when you go to 3 dimensions. All right. But what do we need to check from this function? We need to check anything? Because we're trying to determine if a depth first search finds it. So,
Do our base cases take care of that?
well, the base case will tell us either eventually where we can't go there or we found it. So we basically need to say if DFS returns true, what does that mean? We found where we need to go. And if we found where we need to go, then we need to return true because we know it's correct. Okay. We're going to speed things up just a little. We tried going right. What should we try next?
Guess we can go down.
All right, try going down. All right, what variables do we change here? All right, what are we going to do with CX? Add 1. And it's the same thing. What's number 4? Left. What's number 5? Up. And then number 6. If we tried going right, didn't work, tried going down, didn't work, tried going left, it didn't work, tried going up, didn't work, then what does that mean?
No solution.
There's no solution, which means we need to,
Return false.
all right, there we go. All right, try going. All right, someone fix number 4 and number 5. Oh, that's interesting. How'd you do F4? That was cool. That was cool.
Oh,
Whoa! All right, stop.
You're
Hang
going
on.
to get-
it was cool.
All right, let's try that again. Well, wait. I don't even know why I put you on your line. Hang on. All right, now try it without hitting F4.
I'm scared.
You're scared. All right. Yep, gives you back on there. Great. Now, what about up? Okay. No solution found, returning false. Great. All right. Do y'all feel lucky?
I rarely.
Oh, you know what? We ran. You know what's funny is we didn't actually test it. TS assert. Whoops. Let me get that. There we go. Equals true. Right, because there should be a path from there to there. All right, let's see. Let's see if we did this right, or we get to do some debugging. Nope, fail. All right. So now we gotta debug this thing. All right. Let's see. Let's put a printf or a. All right. We're gonna do. Let's print our current position. Cx. Oh my goodness, C++, you make this terrible. All right, now we can at least see what positions it was visiting. Oh, and I need to include IOStream. All right, so someone keep that on their screen while I'm up on the board. So it started by first going to 0, 1, and then what was the next one?
0, 2.
0, 2. All right, next one.
1, 2.
1, 2. Down here.
And then 2, 2.
And then 2, 2. Right here? Huh. That's not good. Uh-oh. How'd that happen? And then it looped back to itself. That ain't good. All right, that's not good. Let's look at our test case. So we have 0, oh wait, you know what? That's not correct. Our test case is not right. It's 0, 2, 1, 2, and then it's 2 2s right there, as well as the next we have 3, 2, and then you have 0, 1, 2, 3. Why is there a 4 there? 0, 1, 2, 3, 3, 2, and then oh yeah, that's why. Where did that come from? That ain't right. 0, 1, 2, 3. So you still have 3, 2. So that needs. Oh yeah. So there was definitely a wall there.
Oh wait, did you forget 2, 1? Is that a wall as well?
So 2, 1 is a wall. Yes. All right. Looks like our test case was wrong. It's good to check both. Oh, look, it worked that time. Let's go. But it's important. Let's rattle this off and see what it did. What path did it take?
0, 1. 1, 1. 1, 0. 2, 0. 3, 0. 3, 1. 4, 1. 4, 2. And 4, 3.
And then it found the end right there. Okay, great. Okay. Let's change this up a bit. Let's see. Oh no? Let's see. Hold on. I need to make this bigger. Yeah, I'm gonna have to make this bigger. Perfect. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. All right. All right, good. Perfect. Okay, let's do this one. First, we need to make this a little bigger, so we got 6, 6, 6, 6. And where do we have walls? 1, 1, 2, and 1, 4. And then we have them on, and we're just going to copy that down. 2, 2, 2, 4.
Is that 1 width?
I'm sorry. You are correct. R3, 2, 4, 5. Okay, and then start at 6, 6, and you're trying to get to 5, 5. All right, I think that's right. Let's see what happened. Didn't like that. Oh, need to call it a different test case. Okay. Well. Let's make sure we have test 2 and test 1 so we can see what's going on. Okay. Oh, wow. Let's follow test 2. All right, where does it go? So 0, 1, then
Wrong day, yes. 0,
I'm going to take a guess here because it's going to be a while. I'm assuming it went here, then 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 here, and then bounce back, bounce back, bounce back, bounce back, bounce back, bounce back, bounce back. Then it went down here, bounce back, bounce back, bounce back. Well, that was pointless. Done. So, how efficient was that?
Not very efficient.
Not very efficient. Let me
Pretty much had to go through every single empty space.
And let me go and make this even more incredibly apparent. We're going to do test 3. And this time, I'm going to put E right here. I'm going to put a wall right here. And then I'm going to remove this wall. So now E is 2, 0, right? And then we're taking the wall out of here. Oops. We're moving it to over there. Okay. Actually, you know what? I take that back. We're going to remove this wall. No, we'll leave that wall there. We're going to leave that wall there. We're leaving that wall there. All right, let's run that again. So looking at those numbers, if it did what I think it did, make sure it's following. It probably went like this. Oh, I probably did this all together. Nope. So it did?
Something like
Can't tell, or?
It actually did the same thing initially.
Yeah, it did the same thing. So it went all the way to the right. Then it started going, oh, so we didn't get rid of a wall. We're missing a 0, 1. Did I not remove a wall? Oh, I removed it in the wrong one. There it is. Now let's watch it. Oh. Because, hold on a second. One moment. Let's set up this test case correctly. So it goes all the way to the right. It goes all the way down. It tries going left, can't do it, and then it's going to backtrack all the way. So yeah, now that I have it set up, it went. Right. Is that hard to see, or do we need more? I can put more print statements if that's hard to see. Is that a little clearer what it did? Okay. All right. Well, that was kind of inefficient. Now, one test case we haven't done that's actually very important is we didn't make sure that it does return false eventually. So we're going to take this one. Which one is this? Test 1. And let's make a full row. I think if I recall correctly here, if I did 4, 1, it should return false. Oops, that should be false. Right. Good. Huh. So we really wrote the code correctly. Good. All right. How are we doing? You see how useful a stack is? Or namely recursion?
Why is it called depth first again?
Because, and that's a great question, because we went the depth. In other words, we chose a direction and then we went the full depth trying to go that way. And then we couldn't find it the full depth, so then we started backing out, trying to find all the ways during the depth of one direction before trying the depth of the other direction. This is opposed to the other one, which we're about ready to do, called the breadth first search, in which case you're going to start here, and then you're going to try these two, then you're going to try these two. Oh, look, you're done. All right. Great question. Any others? Y'all are so tired.
Yeah.